information for the event.
All right, guys, so we're going to go ahead and get started. We have a slight change in the talk today. We appreciate
Nobody uses it.
Todd being willing to jump in last minute and come talk to us about databases.
Twitch follower.
So to get started, obviously, this is the Go Utah Go user group. Happy to have everybody here. Just a reminder, the microphones in this room are good. It's the square boxes with green lights. So if you're having a side conversation, people online will probably be able to hear you. They are, yeah, they're going to zone in really quickly on things that people are saying. So just be aware of that.
Oh, darn.
Jobs and hiring. So Forge Slack is where job stuff gets posted. If you're looking for a new job, if you want to network and find somebody to come work at your company, the Forge Slack is the best place to do that. And we also have a lot of fun conversations outside of hiring and jobs about Golang and data, AI, all sorts of stuff. Check it out. If you want to speak, we pretty much have an open policy with speaking topics. We have occasional proposals that we have to, we want to work with you a little bit or shop it with you a little bit. But for the most part, if you want to speak, submit something, we'll get you up here in front of people, even if it's like a fast lightning talk or not like a full session. So you can submit you can submit something at the paper call, or you can just talk to me and Carson, hit us up on Slack. And we'd be happy to get as many members of the community up here talking about Go as we possibly can. Go West. So Go West is on. It's actually going to happen October 27th. Here at Weave, right, is where that's taking place. So tickets are available. Go online, get your tickets, come hang out. It's gonna be a fun time. It was great last year, so it should be a good time this year as well. Cool. Well, with that, we're gonna turn the time over to Todd to talk about database access with more Go, which we always appreciate.
It's like Weave Space Cares or something like that.
Now, the terrible
I think it's Weave Space Cares.
share.
Definitely good. So it is work with.
Or it changed. They just barely changed that.
Oh, yeah, okay. A slight delay, it's usual, but it's. Sorry. Okay, so I'm Todd. I'm here to talk about database access stuff. Very last minute, I wrote it literally last night. So there will be a lot of ranting and not a lot of like interactive code bits or anything like that. The code bits that are there are either from public documentation or old projects that I've worked on that are relevant to the need. I have been doing this for a very long time. I feel very old. Up a bio. I have been writing. I'm not like a language specific. I'm a hater of all languages, some more than others. I've been paid real American dollars to write or exposed to, let alone know, including COBOL. Fun fact. Like I said, I'm a hater of things. That's known to everybody who knows me. It's not a bad thing. It just means that I hate things like Kafka. Hey, talk to me about office politics sometime. I am a VP of engineering at a company called Matthews today. This is not my first executive role. I don't like being in management, but I somehow get dragged into it a lot. So if you're interested in that career track, you can also talk to me about that. And other than that, I come from pre-internet times and where I learned on open source, not from a book, well, from a book, but also from like open source communities and computer clubs in the area that my parents were kind enough to take me to. That is essentially like my claim to time is that era ended with my teenage years for everyone, and we can never go back. So if you want to reach out, I'm Todd Punk everywhere. That toys are sold. Oh, with the right click. Okay, so let's talk about database access modes. Specifically, we're talking about ORMs, but I want to generalize it a little more because ORMs get a bad rap as if they're like a thing. They're not a thing. They're a collection of possible things that meet different needs for different people. So we're going to talk about that. But This is also strictly related to relational databases. We're not talking about Mongo. We're not talking about NoSQL of any kind. Those have different access modes and different trade-offs that are just outside the scope of what I wanted to talk about. I was asked about a specific technology and I expanded from there. So with that in mind, let's talk about all the languages that I have worked with databases. C, it was the option at the time. If you are familiar with the old ways of C, you can specifically see why this is a nightmare and you should never do it. But even modern today times, it's not great and you shouldn't ever do it unless you absolutely have to. Then it's all right. You're getting paid to do it, whatever. I then moved on to .NET and ADO or Entity Framework. They're related but not the same. If you're in the .NET ecosystem, we could talk about the banter of where one begins and one ends and ad nauseum go crazy. But it's a very different world that I don't want to dive into ever again, but it was a very big departure from C world. PHP was where I first got into heavy into SQL, and we will talk about how important that is in a minute as well. Before it was just, I was being taught how to use the Entity Framework and stuff. Yes.
Point of order, it's not dead.
It's a zombie. We can call it whatever we want.
Okay.
I know it powers all the internet. WordPress.
Talk to the WordPress people.
Long we stumble along, but no, it's in my book. It's dead.
Okay.
I have done all of the Python things. The Django ARM is heralded by Django people and not anybody else. And I will be talking extensively about SQL Alchemy. It is my gold standard. We'll talk about why in a minute, but this is very important because on this journey, I had already had quite a bit of experience with working with different kinds of things. And now, since then, I've covered it in a dozen other languages, including Ruby and whatnot. We're going to talk about Go specifically, and we're going to compare it to SQL Alchemy. So this is SQL Alchemy. This is straight from the docs. This is like a core kind of example where it's setting up a table and you create the table. It literally is defining everything for you as long as you have, in this case, a SQLite database, or if you have a Postgres or MySQL or anything else relational that it works with, it will create all of the things. It will create the tables, it will create all the indexes, all the things you tell it to. It will manage that whole layer for you. I don't advocate that, but this is not quite as ormy as most people would assume, because when SQL Alchemy started, the lead maintainer is named Seek, online anyway, in the world that we all care about. He hated ORMs, and he was totally against ever bringing an ORM to it. And it was only after lots of online flame wars and discussions on the project that he finally kind of opened up, actually, we could do this right. I think he did. We'll talk about that. But you can see the normal column things. If you don't know SQL, you're not going to get much out of this talk. So I apologize, but keep it in your back pocket for later. But you get all the normal types and whether it's nullable or not, all the things you could possibly want in a relational database. Some of those features are not implemented in every database engine. SQL Alchemy does not care. If you have language or technology specific stuff, you can access that. We do that with Postgres all the time. There's Postgres specific features that we want. So we run with that and you just import it. It's a sub-library module thing. This is all Python. If you don't know Python, just pretend it's pseudocode. That's what everybody does anyway. So this is an actual ORM object. You'll notice it's a class. This is from an old project that I worked with on a company called MobileSense. They do cell phone automation. Most of their work is in database land where they are doing all sorts of reporting and such. So it's a lot of extensive database stuff. The CTO there, his name's Lane. He is a fantastic mentor for data and database access. He comes from the IHC land on mainframes and record stores, and he has extensive experience on managing data over a lifetime of a project, over a company, etc. And this is what we decided to use for all of the rest of the project. And you can see like it's very similar to the non-class based one, but there's all sorts of extra information. For instance, this relationship that is building a binding from one table to another and tells you about how to access that. It will have same defaults, but if you want to override that behavior because you have a special snowflake case, great, you can. SQL Alchemy is great at giving those options with same defaults so you can dive in deeper if you need to. This is not very revolutionary. We have this in literally every ORM out there that uses structs or classes or something like that. So let's talk about that MS base that it's coming from. This is just adding a single extra helper function to this, to all of the things that inherit from it. So all of the database access models get this wonderful toDict function that will reflectively get every attribute and make essentially a dictionary of base types that I can then easily marshal to JSON. And it's very nice. That took, I think, 10 minutes, mostly of reading the docs to figure out how to do it. And it solved so many problems for us. Marshalling is going to be a very, very big theme in this talk. Keep it in mind, because that solved all of it for us, all of it. So let's get into something meatier. This is a function. It has nothing to do with any of the ORM models. Nothing. You call this function, it's called the security clause, because it is used for narrowing down what objects you have access to in the database based on what your user is, what roles you have, what your manager is, or who you manage in the database. I don't need to talk about the structure of the database because the point here is that I am augmenting a query. I'm passing in a query and a database access mode to this function, and it is going to take the query and it's going to reflect upon it without going to the database and say, do you even have a reference to the user table? And if not, I'm going to start diving through the relationships until I can find a join path to the user table. And I'm going to build the filter, which is a where clause, against that makes the most sense across that join graph. And as long as I can do that, it will work. And we've tested this on hundreds of thousands of queries, not hundreds of thousands, thousands of queries that are very complex. We have report framework stuff that we were converting from 4,000 line SQL files that were being run to SQL Alchemy. And it was a godsend because editing those SQL files was fraught with peril. And here, we don't even have to edit all of the things to change the security clause. If we want to add like a new role that has new flavor or something, we just change it here, everything changes. Performance still goes at the speed of SQL. It's still just as many joins as you would need anyway. We'll talk about optimizations, I guess, in a bit, but it was great. It was so awesome. Here's more things you can do with SQL Alchemy that I've never been able to do in any other ORM ever, before or since. This is a bunch of queries, okay? But they're not full queries. They're pieces of queries. They're snippets of queries. For instance, this one is a case statement. It's a single case statement that I can then reuse in the report 17 times, and it will just spit out the same SQL where it needs to. It will evaluate this when it comes to compile time to make or build the SQL request that I'm trying to execute. It's great when you have complex queries. This is not the case for most ORMs, which are trying to make the basic access models easier for you, not managing your complex queries. We will get into why I'm very frustrated about that mismatch in a bit. But this kind of thing, you don't realize how important and amazing it is to stay in your language and make a Pythonic SQL statement that you can then reuse and manipulate just as any other Python object. It's so good. It's so good. If you ever get into Python land and you just play with databases, just try SQL Alchemy and just try doing some crazy crap because you can. Anyway, so let's talk about Go in reflection of SQL Alchemy. and go to GoWestConf.com, get your tickets. It's October 27th, etc. This is GORM, and this is where we actually started our Go database ORM journey. Before, we were just writing raw SQL and running scan against the PG driver stuff because it was Postgres or Cockroach for us. There's equivalents for anything, it doesn't matter. The point is, GORM was the first ORM we took to try to save some of our sanity in trying to build structs, marshal them to and from, because marshaling was the only problem we actually had. We don't have a problem writing SQL. We have a problem taking time to write SQL that we've already written 1,000 times, and we can't manipulate very fast. And we have 3 developers and we need to move fast. So we're doing a whole lot of code gen stuff, but we were using GORM to try to save time while we were building that code gen stuff. That might have been for GORM. It turns out it is. Spoiler alert. But it's kind of nice. This is just it's taken straight from their docs. This just goes through and gives you a struct with some fields like you would expect from any GORM or any ORM at all. And then you can do the schema management as well. That's a big feature in a lot of ORMs. SQL Alchemy does do that as well, as we talked about. But you would probably use something else like Alembic, or in Joe's case, we use Goose to manage all that. We don't want magic. Magic bad. But it can do that. And then all your normal read, update, delete functions, just go with it. It's not hard.
Are they
Makes sense.
ignoring the error returns from all these for brevity?
Yes, it's an example. So this was fine and it worked well until it didn't. The story for us is that we had some nested transactions where we're trying to get a thing, table A, and it has a whole bunch of references to table B that we want to get those children objects of, common thing. We also wanted to save it that way. So we would have things with child objects that you would be like, all right, please make with the happy. You're an ORM, you could figure out whether you need to do this first or after, or whatever. And that was fine, except we would get all of the IDs, which you would expect not to change, would be changed in the return for any updates of any certain complexity. Like there was a certain set of code paths that would happen, and luckily we caught this in testing, so it's not like it, overwrote production data or anything, but it was very disconcerting, and we were sizably annoyed at this is not tenable. We can't put this into production if it's going to change IDs. That's one of the most sacred things in your database. So we abandoned it completely, threw it out as fast as possible, and we moved to a few things. One, we tried SQLX. We tried that for a month. Yes.
I would have thought that technology would be damaged if it did that to you, and it would never do that to you. So how could someone put out this project if it changed your IDs? I mean, so
that is what we were looking at when we were finding issues of people having the same experience. Like we have a GitHub issue that we chimed in on, and like, yeah, we're having this issue too, and they were like, you're doing something wrong. We don't want to dive into it and close it. But and it turns out, yes, we were doing something wrong. But what we were doing wrong was not obvious because magic black boxes are dangerous in that way. And we will come back to that, but good question. So SQLX is one of the things we spent probably 3 weeks on, and it's okay, especially if you don't like ORMs. SQLX is perfect. It lets you write and execute parameterized queries. Amazing. We're now done with all the things it will do for you. It doesn't do anything. It doesn't help with marshaling. It can, if you have something else that matches its expectations for the magic things that you're going to write, it can marshal into a struct like that. But it has to know, and you have to tell it. So unless you're doing a lot of code gen in other areas, like your struct gens or something like that, it's not going to do a whole lot for you. And we ran into the same problems of, this is so much boilerplate. This is so much marshaling, generating a struct, etc. I should also mention here that we have been very much trying to use protos as our source of truth. not database schemas, not what's in the database, Protos. API contract here. What happens in the database is unrelated to the Protos, except that it is related. We don't generate the database schema off of the Protos. We generate the what?
Welcome to the magic of Google Meet.
But I didn't do anything.
Doesn't mean it.
I'm not even in there anymore.
Oh, yeah, you go.
You left.
Who kicked Todd from that meeting?
Did your computer fall asleep for a second?
Oh. Well, either way, while that's rejoin or something. Oh, hey, there we are. Yep, I know it's muted. Please stop talking.
We're kicking Todd out of the meeting.
Don't get
Please avoid kicking me out of the meeting. When something has to be like implementation detail changed, like if we're changing from say Postgres to Cockroach or MySQL or whatever, we don't want to have the API contract change. So we have essentially a generation of all of the Go code and all of the front end code from the Protos so that you have simple access methods for all the basic CRUD operations that you would want, plus the option to add more business logic right alongside the same package. It's in the generated package. So there's a whole bunch of generated files, and then there's a whole bunch of files that we added and coded by hand to augment that behavior. So like you can get things like more functional search or integrating with other search things, which we do actively right now. That's not available for us in SQLX. We were generating that, but it was just, we have to write generators for everything else. And they're all brittle. Because the moment you change, like add a field, you got to change all of these queries where you care about the field. And you can't just tell it like, oh, take all the fields, match their names and shove it in here. You have to tell it like, okay, for this struct, person name is person name, person ID is person ID, and just like all the mapping. So you're maintaining the same stuff in multiple places, and we needed that. So we abandoned it. Even though it's nice for people that don't want worms, we wanted more. Your mileage may vary. I'm not trying to advocate like one path is the correct one here. I'm saying our needs are, please get us out of generating code land and into writing business logic land. And it just didn't help with that. SQL C, very famous. This one's kind of weird in that you write your queries and then you generate Go code with it with a command line tool. And you hope that that goes well. And then you use those structs and whatnot and access methods to do all the things. These are just like weird to work with because it's all just context free. Like they're in a file somewhere. You can put it in your Go file. You can put it in a completely different repo. It doesn't matter. As long as it has access to that and can process those SQL files, it will spit out the right Go code. And honestly, we've had some success there. We mostly generate the client stuff for accessing the database from those SQL files. Means we only have to update fields in two places, the proto, if we're sending it over the API, and the SQL file. And that's pretty good.
And it generates your code, right? So it's really updating the code as well. But
It does end up in the code, but we didn't write that, so we don't count it, you know. So yeah, like it worked well. We're still using some of it to this day, mostly because we don't need to switch it right now, but we will be ripping it all out in favor of not this. Sorry, I forgot about Bun. Bun. This is again right from their docs as an example. It's just doing the same thing like you would expect a query builder kind of thing to do. At the end of every single one of these lines is a dot saying like, we're not done yet. And it's really kind of a single flow, functional, brittle, not helpful thing. But this is honestly the closest thing I found to SQL Alchemy in the Go universe. I'm way open to being corrected on that. Please, if you have SQL Alchemy and Go, I will do all the work to switch right now. I want it.
does it have to execute anything for you, or is there ways that you could just use the query generation part?
So that's kind of the lacking bits is Bun, goes well with the Bun router as well, by the way, which is kind of interesting. I like it, but it's kind of not production ready yet. It's kind of lacking, and there's like a lot of holes where it's like, oh, if you combine these three functions in order, there's an edge case here where if you have a timestamp, it's going to be in your local time zone instead of UTC or whatever. Like just weird stuff that we would run into. And so after like 2 days, we were like, nope, cannot do this. We need trust in our database access modes. Data is the Fort Knox of every company, whether the execs believe that or not. And we just couldn't do it. So we are watching Bun. Correct. I am watching Bun and hoping that it gets somewhere. But most of us on the rest of the team has basically moved on. Hopefully this is Gorm again. So we're back to Gorm. This is our proto. It's not Gorm at all, but it does have this option GormOps ormable true. Opt in for a per object basis in our, or per type or message as it is in proto land basis for, do you want to generate a struct for using with the database? And that same struct, because we are writing proto-C gen go stuff, that same proto will generate both your database access methods, your search access methods, all of your JSON marshalling code, and you will basically not have to worry about, is this coming from JSON? Is this coming from gRPC? It works with the gRPC gateway that we're also generating stubs for, etc. It's fantastic as far as reaching our goal of not writing all of the boilerplate code for CRUD access. It also still gives us the access mode that we need. If we're writing like a report or something and we need to write a whole bunch of custom SQL, it doesn't care. We just have to do that one thing, that one report, that one off, whatever you want to call it. We generate that code by hand, and we do the marshalling back and forth. It's usually sane because it's usually read only. You don't really like update a report. You just rerun it. You know, it's very, very nice. It's so nice. We're using it in 3 different products now. It's been very robust. But before we went back, do you want to ask now or wait a sec?
I'm just curious, is the @go tags related or just something that you've got in this file that?
Oh, the @go tags. So again, this is our proto.
Yeah.
In one of our projects that like is a real proto we're using. All of those go tags are things that we want in the structs that also, since we're using go fake it, all of our tests can generate anything that's compliant that we can pass this string direct to go fake it, and it will generate a number between 2 and 3, or random with certain distribution, regex, things like that. It's pretty awesome for just not having to write a whole bunch of code. So yeah.
So that's a general, that's part of the Product Gen Go.
I believe it is.
Separate thing that does the tags.
I believe it is a plugin. And I can even tell you what plugin it is if I look at the code, but it wasn't in the slides, so I don't know.
Okay.
But yeah, like we just have a bunch of Proto-C gen that all kind of shove stuff into a bigger client forever.
So but it's not related to Gorm. It's just a different thing you're doing.
It is related to Gorm in that there are Go tags that we have, like the same structure. The same structures that are generated will have like these same Go tags, including like JSON data or what if there's like some sort of override for Gorm to like, okay, you're going to need to translate this from underscores to snake case or something. Like we have those availability options because sometimes we're working with stuff that we didn't actually, we inherited, So we can override stuff, but saying defaults mean we don't have to. We do tend to say we will always do, it's not really in here, but we will always do camel case in code and snake case in APIs, like JSON blobs, stuff like that. So we did have to solve the problem of our IDs being mismatched, which again, we dove in and we actually got on the horn of a couple developers who had a lot more experience with Gorm. We're very much fans of it. Always find an evangelist if you want to like figure out how you're doing something wrong, right? They basically told us that, yeah, the transaction begin stuff, that manager stuff that we were using, it's called X, but it doesn't mean X. It means that you should only X if you're only doing this, whatever. So they taught us how to like, okay, if you're going to do a sub transaction, this is how you do it. You have to pass the transaction object into the function that's running the transaction and then pass that through. It all made sense when they said it, and it made us feel really stupid, but it also made us look at the docs and like, it's not in the docs. And you know, that just happens with any project. Some things are not in the docs. So I don't know how we would know, and the naming conventions, naming things is hard. I get that. I'm not blaming like the Go or the Gorm devs for missing something. I'm saying we struggled because there was a big gap between our understanding and our expectations. And the stuff that like, we didn't just like assume it and write the code and then like ship it to production. We have tests, but the tests were doing what we thought they were supposed to be doing until you had nested transactions for sub objects, until you had, like, I have an array of contacts that are in my contact list and they need to be ordered. So I need to put that in the request and save them all at once, right? And it would save them not at once at all. It was all weird, and it was basically telling us, or it was doing what we were telling it to do. We just didn't know we were telling it to do that. So always test more complex scenarios, I guess, is the lesson there. And always find an evangelist to tell you how you're stupid. So that's our protos. This is the struct that it will be generating. And you can see, again, the fake it stuff. All of the extra JSON stuff is implied unless we overwrite it. You can get nullable, you can get, you know, things that will only constrain themselves to between 1 and 3, whatever the case may be. We get enums. Yeah. So yeah, this is pretty approachable. We didn't write any of this, and if we ever edit, like add another field or something, it'll rewrite it, and all the code will still just work, and it's fine.
I'm not saying the part of that that's Gorm specific.
That's the thing, is like, it's just using structs.
Okay. So,
Right.
but without the Gorm, you take the Gorm plugin line out of the proto and you get the same file, right?
Yes.
Okay.
Which is exactly what we want, because we want from proto to a single Go struct, not marshaling into a Gorm specific one.
Gorm's got helpers to help you manipulate this struct.
Proto buff, the proto gen stuff that we're doing, and Gorm will just take normal structs as long as the naming conventions match.
Okay. So what got generated because you added the Gorm plugin line to the proto?
Let's see this.
Okay. That was my question. What you added the plugin? What's the difference in the results?
So this is, again, it's just from our proto generated stuff. You don't need to read all this. I will be telling you all the important parts. You just see the structure. It's not much code because most of the actual like implementation of the API is behind in the storage interface. There's like several layers, and it's fine because it's like 3 function calls to save to a database, and we don't care because we didn't write any of it. We have upsert users. We do everything upsert because we don't want to actually worry about whether you're trying to create or update, because that's a weird thing to keep track of. You either have an ID or you don't. If you didn't keep track of your ID and you actually wanted to update, what the hell are you doing? So we have upserts. It will do all the logic in the user protos.upsert function to slam it into the DB, whether it on a list of objects, it will per object check, do I need to insert or update? And it will do that. It's great. It works fantastic for children, objects, all the things. Lists. Sometimes you want to list, you know, we work in bulk and we want to continue to work in bulk. And then we have like specific ones that are like, get a single user for the people that really need that in their lives. We have several of those. It's fine. We didn't have to write this code, so who cares? Okay, so this is the links. This is also the question slide. You can see our Gen dorm. It's open source. It's Apache. I think we're never going to charge a BSL license or something to it. Just if it's useful, great. There's like 3 others as well. You can see what we're doing. You can do your own thing. It's not hard. We learned it in a week or 2. We've done it with 3 different databases now. We've done it with 3 different other like search databases as well. It's fantastic. ProtoCGen, very easy, as long as you can template. So, questions? Yes.
Where's the point when it would have been easier just to do it as kind of native Go database package? Just write it yourself. Seems like there's a lot of complexity you've added to this. You have to have a lot of substance there before you get your payback from just kind of running the database layer yourself.
Yeah, so I can't answer that for everyone. I can only answer that for us. We have 3 devs, and we are writing a massive platform that we honestly have no right to do with 3 devs. And we, I think, are 1.8 million lines of code or something like that in that code base. We rely a lot on CodeGen to take all of the boilerplate to marshal things around that we don't want to do for the basic use cases, because writing the SQL by hand, writing the marshaling code by hand, writing the code for marshaling from database land to JSON land by hand, all of that kind of added up for us. For a certain use case that isn't just a simple CRUD app, because I mean, it's a commercial real estate company. We're not exactly like changing the way APIs are written or anything. So the basic CRUD model works. It just saves us a lot of time. If I had a more complex use case, the math would look different. Yes.
So in your use case, do you have an actual API that's almost one-to-one with every query you're ever writing? Because so like what happens if like you create protocol buffers for things that don't have actual API endpoints just to get the struct so you can query the database?
Also, no. There's nothing in the database that wouldn't be accessible through the API. It's just a matter of how. For instance, like we generate the API for users. We don't manage their passwords, but one of the use cases that we know is a thing that we want in other projects is you can send in a thing, but you should not get that back ever. You know, so we will write the API first, and it will coalesce like what should a user look like. You know, so there's types, and then there's things about those types that aren't necessarily in the RPC services. So
it's still like a data access layer. Like
it is definitely a data access layer. But it also hooks into like a lot of the things that we do with the backend that we believe that it should be dumb as all get, as dumb as possible. But we do things like, I talked about this before. We have a bidirectional sync with Salesforce, which is the actual source, the golden source of our data. And everything that changes in Salesforce, we are constantly pulling on their endpoint. They have a bulk API that you can say like, give me anything updated in the last like 3 minutes or whatever, or since this timestamp or whatever. And then you can paginate through that. So anything happens over there, we need to get over here, and we use our own API to do that in just a sync that runs in a separate pod in Kubernetes. But we also have this the other way. Anytime you change something in the database, we want to submit that to Salesforce, sometimes in transaction. So we want to make sure it's going to go to the database, it's going to work, and then we'll submit it to Salesforce, wait for that to confirm, and then commit the transaction. You know, we have weird retry stuff and all that as well, but all those caveats and stuff were just hand-rolled code that we didn't have to then write because
at least get
we had all the we had all the separation of concerns. So like this layer and this layer and this layer, and it's like, where do I add it? Not to any of those layers because it doesn't matter. Those don't care. So we just added into the event loop of when it comes in, it needs to do this. And so we write very little of that code, but there's a lot of complexity going on for like, we need a background task to reindex something. We need to update search. We need to like, so all of that is more of the complexity that we do add. And it's just not related to the Protos.
And you might be microservice anyways and wanted to have even a facade of an API and still have that protocol buffer so that.
Yeah, we're largely a monolith, but we set it up such that it will be easy to break out because monoliths aren't bad. You just need the engineering discipline and they tend to not encourage that. And we're just automating the engineering discipline as much as possible. So we don't do that ever. And then if they ever need to like split it up for whatever reason, we just never cared. So those services are really easy to just break out, but they're all in one big thing right now. And you just have concurrency, other workers, things like that.
What percentage do you think roughly of your queries are generated with product and GoGorm versus ones that you kind of create outside of that?
The only thing that we've handled, other than all the SQL C work that we did and still reuse right now. Such a waste of time. The only thing that we've handled is a single report, which is more for another group to get some statistics about usage and whatnot. And that isn't even using any of them or the types that we're using. We just hand rolled that because it's just the database and we just add it. It just needs a.
You're
I'm not sleeping.
dropping off the Wi-Fi.
It's connected. Well, I guess it's not important, but yeah, so we only have one so far. If we write the report framework stuff, I actually might just spin that up in a Python service instead. Because it's so much easier.
So you're doing, you know, pretty basic CRUD stuff, like a big majority of that.
Mhm.
What do you do if you need to break out into some like more like, you say you've got Gorm and Gorm generates your creates, your deletes, your gets.
Well, Proto-Gen does, but yes. Proto-Gen Gorm does.
So you're generating those. What if you need to do like more interesting database specific things as part of that, right? What if you're selecting not on string this equals string that, but like Postgres has got some JSON native types and searching. Get all the persons where this JSON blob has a map of these keys. Like that's.
So actually, Gorm has a lot of the facilities for that, and all of our objects in the Matthews world. Sorry, that's not my alarm. It sounds like my alarm music, but it's not. The critical path for us is the Salesforce object. We have all of the Salesforce data in our database because we have a object with 496 fields. We did not want that in our database.
It seemed like a magic number.
So it's 4 less than you can actually have in any Salesforce object. 500 is the limit.
Okay.
Ask me how I know. So we didn't want that in there, but we didn't want to actually have to go refetch like all of the times stuff anytime we added a field from the Salesforce object to our object, which we do all the time. We do this all the time. We added 17 fields today, I think. Something like that. And again, it's all just generated. Just add pull request. The Salesforce object is in a JSON blob on there, and it's cockroach, but it's the same semantics, same wire protocol as Postgres. So Gorm has facilities for accessing the JSON dialect in Postgres, and we do that. Typically, we're not using that much because we don't want people to like get it on the front end or anything like. That just seems like a nightmare. Like you're just going to use that instead. And we'd rather have first-class citizens of fields on our database tables that we know matter and aren't just cruft left over from somewhere.
Sure.
But it allows us to do like migrations where we can do the selection. And we just do that in SQL because Goose is totally easy to do.
Yeah.
And so that's handled in SQL. But the JSON access is still there.
Okay.
It's totally doable.
And you're,
Enrolled SQL and Go, you're not writing Python scripts for that?
No, not at all. Goose is, we use the embed.fs. Goose has a bunch of migration files.
so nice with
0.00001 and
So
just work
nice.
up and it runs them in order. We have a separate job that on roll, it will run through the out of band. So service is still up. It will run through all the migrations. When it's finished, then it will roll the rest. So every upgrade does the migration. And however, if it takes a day, we screwed up, but we haven't taken down production. Goose is nice. Everybody should be using Goose if they're in Go for their database migrations, bar none. Unless you're doing some sort of other weird code gen. And even then, you should be doing code gen into Goose and then
And
it's great.
so one more, sorry.
Yeah.
Your end result of all the form stuff is the CRUD stuff, right? You don't get any, I can see how in SQL Alchemy, you can have it do that query gen magic.
Go to the database and marshalling out to gRPC
Okay,
protos.
so when it gets to those, like, this is not a solution for all the magic cross joining, and like a true ORM has so much data, it can do this kind of like, I will find the join paths and I will get you that and just make it work all the time. You're just trying to get away, that you still have to roll by hand if you had to, right?
No. So relationships are still in there. But in the proto world, those are just like, I have a user and it has contacts, whatever. So like repeated contacts, whatever. Like, protos.
Yeah.
You can have messages that are other types. So like they're kind of nested objects and it will roll that. It will roll that. And if you include, well, if it's required, like if it's repeated and it's not optional, you have to have one. And if it is optional, then it will add an if statement to say like, is this here? If so, we need to go insert it or update a whole bunch of other rows. And so it generates all that code.
So if you've got a person
Mhm.
and that person's got a list of contact like addresses, and that's another type, the generated GORM helpers for like get person with this ID will join the two tables in order to select all the stuff to populate that person, including the enumerated stuff from this other join.
And we tell it based on the API calls, what it needs to generate.
That's pretty cool.
I can't really show examples from their code base, but because I don't know it, but I can show you like off record. It's recorded, right? I don't actually mean that. No, I'm just kidding. I can show you what it ends up with, or you can look at the Proto Gen GORM. It's just templates all over the place. So
Okay.
it's not too bad. But yeah, we do take the types in and out of that. If there's anything internal, that's where we end up doing the hand rolled stuff. And even that, like, it's got all the helper functions. So like if we have a bunch of background tasks. For instance, like searching requires the index in search to be updated. And sometimes that takes a long time and we don't want that in the request because they're not going to immediately search for it. So when they create an object, unless you override that, it will have a single thing that will submit to corn dogs to say, here's a background task, please index, here's the payload, whatever. That is actually run in the same pod with a worker concurrency channel. And it will pull that task and it will go to the database and access it, process it into an Elasticsearch proto, shove it in there. Like we have those translations that we've hand rolled, but it's very little SQL. Like there's not a whole lot of complex SQL that we end up needing outside of reports. There's usually just like filtering on, well, do we need to transition like from an epoch timestamp to an ISO 8661 timestamp or whatever? Like those kinds of marshaling questions are the vast majority of our pain that we experienced last year. And that's what we have been writing all of this generated stuff to get rid of this year. Your mileage may vary. If you have a lot of bespoke hand-rolled custom SQL, I do kind of question what you're doing, like that needs that in an API accessible way. If I was writing just an app that wasn't like an API backed thing, the math is very, very different. And I'm not trying to say that this is the way or anything. I'm trying to say you can generate a lot of the pain and take on the pain that you actually need to. For instance, if I needed to write the hand rolled thing for like a one-off API access thing that just was going to be like, I'm going to take a whole bunch of things from these three and summarize it into an object that can be used in a report somewhere else or something like that. Contrived example. I would just hand roll that. I would just use raw PG driver or SQLX or SQL C or something. GORM allows you to just write a thing You don't have to use it with like its objects. It will execute a query. You can do that and then do your own scans with your own protos, and it will have some helper functions. I don't know. It's already included. You just write a file and call it. So your mileage may vary, but that's where I would like dive into that. And that's actually a requirement for every GORM I've ever used since PHP time is, can I drop down to raw SQL? And if I can't, then it's not an ORM, get it out of my face. So I've always been on the SQL train, but I've tried to avoid it because most places don't need it. That said, web services are very different than like game engines, things like that. So.
What do you miss from SQL Alchemy? Like, what's you obviously put SQL Alchemy on a like high up in terms of like what this is the gold standard.
Yes.
And like, so where are you now, and what do you miss from over there, from where you are with GORM?
So there's a lot of things that I have done in my time that are not web services. And like I've said just recently, that would change my calculus. I don't miss anything in the current projects because they're all web access stuff. All the like complex stuff where we're combobulating things into a table that's interactive or whatever is all done in JavaScript, like you have to in the web. But it allows us to do all the security stuff. It allows us to do all the normal things we care about. I miss the ability to build clauses, to build pieces and extend them and reflect on them. And I would care more in a lot of other projects that I've done. I wish I could just share the joy of being like, looking at a 3,000 line SQL report written by somebody who literally died several years ago and spent months maintaining this, and like translating that to SQL Alchemy, having it take, instead of an hour and a half, having it take 40 seconds, and then being able to like further refine that. And you're looking at 3,000 lines of SQL or 280 lines of SQL Alchemy, because a lot of the things are repeated. A lot of the things are reference, not. So it's like a really great thing if you know SQL already. This is actually like one of the biggest seller to me of SQL Alchemy was always, Zeke said, you cannot use SQL Alchemy effectively if you don't know SQL. It's not saving you from learning SQL. SQL is easy, just learn it, and then we will make it even easier. And that attitude is surprisingly lacking outside of SQL Alchemy, let alone in Go. Like, that's just not in any of the languages that I've worked with, in any of the ORMs or data access stuff, in any database, really. So it's kind of sad. But that's the sort of thing I miss, is just being able to like express myself in a higher order language rather than a rigid SQL query. And then, you know, it translates to SQL at the end of the day, but like the intent can be at runtime rather than I have to write SQL for every use case or write my own templating engine for every use case. For instance, that security clause that I showed, that would be a godsend in so many places, even web services, if that is the security model that I need to work off of. I don't, thankfully, but just being able to say like, look, I don't care. I have a query, it has a bunch of tables referenced, you figure it out. That would be amazing. You can't do that in SQL, and none of the ORMs that I've talked about other than SQL Alchemy will help you at all with any of that. Because you don't have the join graph, you don't have, there's some bits of it in some of the ORMs, but it's all like inferred from Go land, not your SQL expression land. You know, it's not working with SQL, it's working with Go structs that hopefully translate to SQL. Same thing with like Entity Framework and .NET and all of the others. It's not as expressive. It doesn't feel as fluid, that's for sure. And then it's not as reusable either. Like that security clause was used in like half of the endpoints. And Mobile Sense, I will sing their praises a lot. Jacob's actually worked there too. They have tons and tons and tons of tests. So many tests, over 10,000 tests. And they test everything. And we were using like some of those security clause stuff in a third of those tests. And we didn't even know. And it was easy to like see like how often is this called and like just normal profiling stuff. So I can't even calculate how much time we saved just by having SQL Alchemy. And that's not something that I can have. Bun is getting close, maybe. Caveats that they might never be able to reach that because they're doing like the query builder object-oriented functional thing from like Java land, but
So you won't generate from SQL statements, but generate from protobufs. You were hounding on it the first time that like the SQL generation was bad, but
yeah, it makes sense.
like protobufs are a lot more rigid, so you can.
It's all use case dependent, you know, it all just depends on what you're trying to go for and what you're trying to optimize against. And again, that's why I'm advocating like my way is not the right way. It is the right way for me. I do think that you should be generating. I think you should be generating a lot.
Okay.
Brandon, you're alone.
We'll close it up.
And back to Brandon.